Hello guys, and welcome back to another episode in my CPU showing videos series. Today I'm just going to show you its random generator function, random number generator. There's not really much else to show after that, so I think this might be the last video. It does have more functions, as all the logic functions, and you know, there's obviously other things you could code in, but that's all I've done with it for now. So let me show you that then. So first of all, I'm just going to show you that you can just turn the random number generator on and it will start generating random numbers. But the way I've got it designed is that you have to code it in order for it to actually give you a random number. You can't just expect random numbers to appear. You actually have to code a program as well. So this is how it works. It's just a series of clocks and a piston transistor, you could say. Then what we've got is when the random function comes down this line, when you code it in, the signals get put onto the bus. And here you can see it absolutely random. So yeah, so you have to code it in order for that to work, so I'm going to do that now. The clocks, when you turn the random number generator off, obviously the clocks reset back to like a default setting, so it's a random function, it's a random factor for you to actually turn that on. That's what creates it more random, basically. So if I had the computer coded to switch that switch on, then it'll take the same amount of time to switch that switch on as it does to do the next line in code. So you'll just be getting the same random numbers over and over again, which obviously wouldn't be very good, would it? Right, so the first line of code, we want to, what do we want to, want to write to register A, and we want to read rand from the ALU. And what I'm doing now is I'm going to sort of make it more of a random, the random number more random by adding two random numbers together. So first of all, it'll do a random function and get a random number, and we'll save it to register A. And the second one, we'll get a random number and we'll save it in register B. And then in the third line of code, we'll add those two together, and we will get the answer on the screen. You could even do something like ANDing or XOR or something, just to get it even more random, but this should be random enough for anything. There we go, just 3 lines of code, very simple. Right then, so let's start. And I'll tell you what we'll do, we'll also make it loop back to line 1. We'll make it loop back to line 1 so we can get more random numbers. So we come in here, and then on line 4, we want to loop back to line 1. Well then, let's start. Sorry, just a little bit of lag. God, these chunks aren't doing very bad. Okay then, so first line of code, we're getting a random number because the random number generator is on, and we're saving it into register A. Next one, we're getting a random number and saving it into register B. And finally, getting both of those outputs and adding them together. Right then, so hit the button, and there's our first random number. You can see it's pretty random. About half of them are on, about half of them are off. It's expected to see this one on, because if you're adding two large numbers together, it's most likely to come on. Let's do that again. because we got a loop function in, we could just hit this. Saving a new number to register 1. Saving a new number to register 2. And adding them together. This is our new number. And there you go. Oh god, what's happened there? Oh god, yeah, I don't know what's going on. It's just the way I've got this screen set up. It will update whenever a new number comes in, but not when a new number goes out, when that number goes out. So if you get like a number added together and it's ripple carry, obviously some bits will come on and then they'll turn off straight away, so that's why the buttons are. As you can see, another new random number. And we'll just do one more. Now I haven't actually like checked to see how random they are. I've just know this way of making random numbers works because it is essentially random. All those clocks are at different speeds. But getting like a 2-digit number or a 3-digit number is like incredibly rare because of the 5-digit numbers that exist. But it's just a basic random function. You can't really get much randomer than that before you start going into really weird things. And this function isn't actually used for anything useful, so it doesn't really matter, does it? I think that's our number. Yep. There we go. Make a comment if you you've got a better random number method than this. But yeah, there you go. So I'll just go back over there and show you what I mean if you didn't quite get it. What I have is all these clocks. They're just different speeds of the clock. So, but obviously they're a bit of a bias clock because most of the time they're on before they're off, and then they just get put onto the bus. Each one has a different unique speed. Then when you turn it on, it gets them all out of sync with each other. Then when you hit the button, they get put onto the bus by the piston gate and obviously go along the big bus. Yeah, that's what it is really. And when the actual random signal comes down, this is a little pulse limiter I made. It's my own design. Really simple. It just makes the pulse so it just makes a pulse, so you're not getting a whole stream of random numbers. You get one short burst of random numbers, basically. Otherwise that would mess it up a bit, wouldn't it? You'll get a majority of bits on, and that's not what we're looking for. Okay then, so thank you for watching this random number video on my CPU. As I said, there's not really much else to show you apart from the logic functions, which is a bit boring, so I won't show you that. I am making a new CPU. Hooray! Whether you knew it or not, I might have told some people, I don't know. But I'm making a new computer, a better one, bigger. Yeah, I know, this is already really big, it's going to be bigger. It's going to be a lot better though, it's going to pick up where this one fails. It's going to have way more registers and stuff. But the most important thing about it is that it's going to be designed the exact way a real computer is designed. So I have the exact same registers, the exact same architecture almost. It'll have a two-way bus because in real CPUs you have one big bus that goes in every direction, not just buses where necessary. So this bus only goes one way and everything. Yeah, and then once the CPU's done, I'll upgrade it into an actual computer by adding RAM and program memory. Because this CPU is sort of a mixture of both, really. It doesn't really make sense. Okay, so I'm gonna have videos coming about that, not soon, but I have no idea when, because at the moment it's only in the planning stage. Oh yeah, I've signed up to the Open Redstone Engineers server, which is basically a server just dedicated to Redstone development, and it's really good for if you're good at Redstone and you want somewhere to go for maybe extra help on really complicated projects you're trying to do, or you just want to build in a the community environment of many of the Redstone people. Just go there, it's a really good server. They've got so much cool Redstone stuff on there. So I'm going to be building the computer on that. And so the videos should be on that server. I hope it doesn't lag the whole server though, that would be very bad, wouldn't it? Okay then, so thank you for watching. That's the end of this series, and I've got some more videos coming up soon that I've already planned. Not on anything Redstone. Yep, so see you later. Thank you for watching.